Thanks very much. Real pleasure to be here and to tell you about enabling open science in astronomy. We've had some success in doing this. It's been mentioned, astrophysics has been mentioned a couple of times already in the program, and I'll show you some of the solutions and you know why that can work for astronomy and how it can be a good example in other fields. And we actually have been talking to people in brain science, in chemistry, in earth science, and in other fields where we try and share the experience of how we share data. So I'm Mark Allen. I'm from the Strasbourg Astronomical Data Centre across the road. We've celebrated our 50 years anniversary just recently. We're part of the ESCAPE project, and we're an infrastructure within the French framework. And at the international level, just to give you a really quick overview of what it's like in astronomy, we have physical infrastructures like telescopes and space missions, and satellites, and gravitational wave detectors. They have their archives, they have data services, they produce the data. We also have simulations generated by large computers. We have data centers like the one that I manage, as well as others in the international context who have different specific roles. We deal with the journals in astronomy, for example. We process all of the data that is published in refereed journal articles and populate our database with those references and indexes and citations. And something that's helped us, something that's happened in the astronomy, is that we've come together as a global community recognizing that the standards need to be international, and we've built something that's called the Virtual Astronomical Observatory, or Virtual Observatory. And here we're talking about interoperability standards, and that's been helped enormously by the coordination at the European level to represent European research infrastructures and projects at the IVOA, so that we are really taken into account in the international standardization for interoperability in astronomy. And the ESCAPE project is the one where we are acting in at the moment. And of course there's the links to the other wider infrastructures, whether it be through the RDA, certification like Core Trust Seal, and of course EOSC and commercial cloud services. So a few more words about data sharing in astronomy. It started early. In astronomy, the science is driving it. I mean, we need to combine data from different telescopes that observe at different wavelength ranges, X-rays, optical, infrared, and so we need to combine that data. It needs to be interoperable. And so from very early on, with formats and also identifiers for bibliographic information, there's been a kind of standardization in astronomy. And since 2001, this concept, and in practice, the Virtual Observatory, which is a set of standards that anyone can publish to. There is validation, there is checking. At the moment, there are more than 100 authorities that provide a resource in the Virtual Observatory, and it's implemented in some of those major facilities that I showed you. But instead of the words, let me give you a little bit of a visual example of what I mean by that. The Virtual Observatory allows us to be fair, and we've been around since before we used the word fair, but it's such an important thing that we have this common description of what we mean by open science, and fair is a large part of it. So let me give this quick visual example of finding, accessing, interoperating, and reusing the data. There are many the Virtual Observatory has many portals. It's not a single stop shop. It's a framework of standards which enables tools like this one to be a portal to the data, and we can search it just like in Google. It's a bit like Carol's Google example, where this is sort of like Google Maps for the sky, and we might have a favorite galaxy, NGC 4039, and we can find it very quickly just by saying, okay, find me this galaxy. And in fact, this sort of operation acts like Google. It has the indexation of all the astronomy data out there that's been published, and it's able to tell you, in this part of the sky, what lights up as green is like there is your object, there is something of your interest in this part of the sky, and where there's not, there's not, okay? So, and how do we know that? It's because there's a standardized indexation of the geometry, of the coordinate systems in astronomy, that allows everyone who complies to that standard to publish their map, and it allows us, within the thousands and thousands of data sets, to say, okay, this one overlaps with this one, and this one can find Carol's favourite astronomical source. You can download, I hope you have a favourite astronomical source, Carol.
More than one.
You can download it, you can visualise it. Astronomy is very visual. Of course, it's beautiful to look at the data, then combine it, bring it together. And it's interoperable. Like I mentioned before, data from many, many different facilities, from the Hubble Space Telescope, from the Chandra X-ray Telescope, from there's also, you know, there's 9 pictures there, but there can easily be 200 of them. So those are interoperable because they comply to the standards that enable us to describe the data and to be able to not just look at them and say, well, that's pretty, but you can actually compute do scientific computations on that data. And alongside those visualization tools, we're connected to, you know, Jupyter hubs and the ways of using the code in astronomy to bring that together in notebooks and really do reusable science. For example, here, cutting out different parts of those images and doing something scientific with them. So it's built on this framework of standards. And I talk about this because I think it's an example of, you know, what EOS can adopt. It's a framework of standards with many portals. There's been many lessons learned about how you make interoperability standards. IVA's been there for 20 years. It's difficult. You know, there's compromise. You have to get agreement at international level. It takes time, it takes patience, it takes testing and doing real things to see what works and what doesn't work. There's a governance, which is at international level with national members. And again, the coordination, though, happens at either the country level or European level, and the EC has been extremely important for that. There's an architecture, and you can map FAIR onto that architecture where the real standards exist. They've been published, they're in FAIR sharing, they have DOIs, it's very well established. So ESCAPE is the project that we're in now that's been addressing not just that standardization, but in fact more widely the open science challenges of astronomy, but not only, of also astroparticle physics and of particle physics. And indeed, from my point of view, this already starts to be interdisciplinary. We have the European Solar Telescope, really different sort of data, observing our star rather than galaxies of tens of millions of stars. And we combine astronomy and high-energy accelerator particle physics. So that project is set up so that we bring in the experience of astronomy, and we also bring in the experience of exascale data that comes from particle physics, from CERN and the partners associated with them. ESCAPE has a program which is where the standardization is just one part. There's a data lake, there's science platform, software repository. And it brings out a few international dimensions that I wanted to highlight here. One is that the standardization happens at the international level, and it needs to. So what are the policies, you know, we should have for EOSC so that we can facilitate the inclusion of these international standards into like the EOSC interoperability framework? How do we, you know, it really makes sense to onboard the whole astronomy catalogue as one, you know, because astronomy providers already publish to this catalogue. If we can include that, it'd be great. It's already onboarded to EUDAT, but there's a little bit of an issue about getting that directly into EOSC portal, and I make a little bit of a call if there's someone, the right person in the room, to help me fix that. In terms of international cooperation and competition, you know, EOSC, I think, is, and you know, we're really ahead. I mean, we talked to our astronomy colleagues in the US, and they haven't got something like this, not yet. Next year is the NASA 2023 Year of Open Science. They have an open science initiative. I mean, there's cooperation there, but there's some competition as well, so we should use our advantage. But we want all that to be included together. So I wanted to conclude just with a set of questions, perhaps that helps the panel. What are we doing to make sure that we interface with international systems? What policies can help us onboard whole domain international catalogues when they're ready to do so? I think astronomy is not the only place which has that. and what policies are we putting in place to sustain this level of coordination so that we can continue to be at the forefront of data sharing in astronomy and in the EOSC. So thank you very much.
Thank you, Mark.